Now, for our very first question, I hope that you're able to take a quick glimpse of, we'll take a quick glance of this equation, and you're able to tell what shape it is. I hope you're able to tell that it is a rose because of the coefficient in front of theta. And I hope you can also tell that it is a rose with how many petals? There will be 3 petals total. And you know it is signed, so one of the petals would be on the y-axis, but which part of the y-axis? Well, we will need to find out. So the best way to find out is to analyze when this will give you the maximum R. Well, it will give you the maximum R when sine theta equals, well, sine 3 theta is equal to 1. Now, another thing that you should also acknowledge is that the domain for theta, it's between 0 and 2 pi. And now we have 3 theta. That means our domain would go from 0 to 6 pi. So a total of 3 revolutions altogether. So when you find your value for 3 theta, what you want is to find out the values for each of the 3 revolutions. So the first one will be pi over 2. The next one will be, well, you add 4 pi over 2. Then you have 5 pi over 2. And then you add 4 pi over 2 again. And there will be 9 pi over 2. Again, you add 4 pi over 2 because 4 pi over 2 is equivalent to 2 pi. So 1 revolution. So that's what 3 theta is, but we want theta. So you will divide by 3 or you multiply by 1/3 on both sides. So you have pi over 6, 5 pi over 6, and 9 pi over 6, or just 3 pi over 2. So that means you will have an R value of 4 at these angles. 1, 2, 3, 4, right here at pi over 6, and then at 5 pi over 6 right here, and then at 3 pi over 2. Now, also I mentioned this, there are so many circles here, it's easy to get dizzy when you stare at these circles. So, so you need to make sure that you are counting the units very carefully. And I think that, yeah. Okay, yes. Well, sine of what would give you 1? Sine of what would give you 1? Pi over 2. And then you do the additional revolution. This one? Because that gives you the maximum R. Okay, again, as I said before, I said that for sine theta and cosine theta, they always fluctuate between -1 and 1, just like how you do your graphs back in the days, you know, how it always goes from -1 to 1. So that's how you do your drawing. Okay, so if you can find out the tips of the 3, each of the 3 petals, I'm very happy. Yes. Good question. So how do you know how far? Well, now this is how you should be thinking when you analyze your equation. This is 4 times sine 3 theta. This whole 3 sine theta thing could be as great as 1. It could be as small as -1. So, I mean, if you consider the maximum R, that will be a 4, because 4 times 1 is 4. Now, should we consider the minimum R in this case? Well, what we talked about in class the other day is that we could, but what you find out is that when you have an odd number for the n, it just repeats itself. So you may go ahead and do another set of calculations for sine 3 theta equals to -1. You get 3 separate angles, but the points that you're getting would actually duplicate. So then we say, oh, you just need to do one set of calculations and you'll be fine. Okay. So for the table, so you can say pi over 6, 5 pi over 6, and 3 pi over 2, and they will all be 4. And I'll be very happy if you can show me this. Okay.